To solve this differential equation in this video, we are going to see another type. So this is a new type. Yeah. So this is a homogeneous differential equation. How do you see it? You can't easily separate variables here. So you go for homogeneous, neither is it linear. So we begin by dividing through with x to the highest power. We always divide through with x with the highest power because of the nature and the y that we are always rating. Why? Some people may identify it that way, but others may also identify it in another way. But it is always good to see that you can divide through with x with the highest power. Why? We are also going to see it why. So divide through x with the highest power here. X with the highest power here is actually x to the power 1. So we have x out of x dy by dx is equal to y out of x plus the square root of x square minus y square over x. Yeah. Now, before we rate, why we divide through? Because we have y is equal to u of x. This tells us that u is actually y out of x. So we divide through to create that nature. To create the nature of y out of x. So let us simplify this. On simplifying this, we can have dy by dx is equal to y out of x plus, now this is the same as x square minus y square out of x square. Yeah. Now going ahead to simplify, we can have our dy by dx is equal to y out of x plus square root of 1 minus y square out of x square. Yeah, and this our y, we have to differentiate it. So we differentiate it, our dy by dx is actually equal to u into 1 plus x du dx. Simplifying it finally, we have our u plus x du dx. Yeah. Now, after getting this dy by dx, we are going to substitute it. Here. We are going to substitute it there and the value of u. So, putting it back there, we shall have u plus x du dx is equal to u plus the square root of 1 minus u square. Yeah. So we go ahead and take this u this side. So when you take u that side, we shall get 0. So we shall end up having x du dx is equal to square root of 1 minus u square. So we have that. This will cancel with that. So now we go ahead and differentiate and integrate separate variables first. So we separate variables. When we separate variables, this we shall have 1 out of the square root of 1 minus u square du is equal to 1 out of x dx. So we integrate on both sides. Now when you clearly see this is sign substitution. So that is sign substitution. Yeah. So I'm going to link my video. Those who have not yet watched my video about sign substitution, I'll link it and you can see it. Link in the description. So it is the same as, this is the same as sine inverse of u is equal to actually ln x plus ln k. K is a constant, of integration. So going further, we can have sine inverse, our u is y out of x, is equal to ln of kx. Now we can go ahead and simplify this to becoming y out of x is equal to sine of ln kx. Yeah, and then we obtain our y. Finally we obtain our y. Our y finally becomes, our y is equal to x sine of ln of kx. So from here is where our differential equation originated. Our differential equation that we are dealing with originated. Yeah. Thank you for watching. Yeah, I have to thank you a lot. Thank you for watching. Please subscribe if you haven't subscribed. Please subscribe, like the video, share it because sharing is sharing. Share it with your friend and comment on the video. Thank you so much. We meet in the next